In 1962, while American scientists are laying the conceptual groundwork for what will become the Internet, a Soviet economist stands before the Presidium of the Communist Party with a proposal so ambitious it seems like science fiction. Viktor Glushkov wants to wire the entire Soviet Union into a single unified computer network, not in some distant future. Now, he calls it OGAS, the All-State Automated System. And if it had been built, the world you're living in right now might look very different. This is the story of the computer network that almost was, a system that could have revolutionized the Soviet economy, redefined the Cold War, and beaten the West to the digital age by decades. Instead, it became one of history's greatest technological what-ifs, a monument to brilliance destroyed by bureaucracy, ambition crushed by politics, and a future that slipped through humanity's fingers. This is Blueprint. Viktor Mikhailovich Glushkov is born in 1923 in Rostov-on-Don, a city on the western edge of the Russian steppe. His father is a mining engineer, his mother a teacher. The boy shows an early aptitude for mathematics that borders on the supernatural. At 17, he enters Rostov State University to study physics and mathematics. Then comes the war. The Great Patriotic War interrupts everything. Glushkov survives, returns to his studies in 1945, with the single-minded focus of a man who has seen too much death too young. By 1948, he completes his doctorate. By 1956, at the age of 33, he is a corresponding member of the Soviet Academy of Sciences, one of the youngest in the institution's history. But it is in 1957 that Glushkov's life takes its decisive turn. The Soviet Union establishes the Institute of Cybernetics in Kiev, Ukraine, and Glushkov becomes its director. Cybernetics, the science of control and communication in animals and machines, has been denounced in the Soviet Union as a bourgeois pseudoscience just years earlier. Stalin's ideologists called it a tool of capitalist oppression. Now, after Stalin's death, after Sputnik, after the dawning realization that the technological race with America is real and existential, cybernetics is suddenly legitimate again. More than legitimate, essential. Glushkov throws himself into the work with a fervor that his colleagues will remember decades later. He is tall, intense, with sharp features and eyes that seem to calculate even as they observe. He works 16-hour days. He publishes papers at a rate that seems impossible. And somewhere in these frenzied years of research and theory, he begins to see something that no one else has seen quite so clearly. Computers are not just machines for calculation. They are tools for organization, for coordination, for the rational management of complexity itself. The Soviet economy is complex beyond human comprehension. 20 million square kilometers. 15 republics, 200 million people, tens of thousands of factories, mines, collective farms, transportation networks, all supposedly coordinated by Gosplan, the State Planning Committee, through 5-year plans and endless cascades of paperwork. But the system doesn't work. Everyone knows it doesn't work. Factories overproduce goods no one needs while shops run empty of basic necessities. Resources pile up unused in Siberia while Moscow goes without. The planning apparatus employs millions of bureaucrats drowning in paper. And still the numbers don't add up. The plans don't coordinate. The economy lurches from crisis to crisis. Glushkov believes he has the answer. OGAS, the vision. The proposal Glushkov presents in 1962 is breathtaking in its scope and audacity. OGAS will be a 3-tier hierarchical network connecting approximately 20,000 computer centers across the Soviet Union. At the bottom tier, local computing centers in factories, farms, and enterprises will collect and process data about production, resources, and needs. At the middle tier, regional centers will aggregate and coordinate this information across territories and industries. At the top tier, a central computing complex in Moscow will synthesize everything into a coherent picture of the entire national economy, capable of generating optimized plans and responding to changes in real time. The network will use a standardized system of data collection and transmission. Every enterprise will report its inputs, outputs, capabilities, and needs in a common format. The computers will process this information using mathematical optimization algorithms, linear programming, input-output analysis, the tools Glushkov and his colleagues are pioneering. The result will be a living, breathing model of the Soviet economy, updated continuously, capable of achieving what no human planner could, true rational coordination on a continental scale. Glushkov estimates the system will require between 15,000 and 20,000 computers of various capabilities. This is an astronomical number for 1962. The Soviet Union has perhaps a few hundred computers in total at this point, but Glushkov argues the investment will pay for itself within a single 5-year plan through improved efficiency, reduced waste, and better resource allocation. He calculates that OGAS could increase Soviet national income by 10 to 15% once fully operational. The technical specifications are remarkably prescient. Glushkov envisions packet switching for data transmission, though he doesn't use that exact term. He proposes distributed processing rather than centralized mainframes. He designs protocols for error correction and data verification. He even sketches out plans for what we would now recognize as early database management systems. In many respects, his vision anticipates elements of the internet by decades, not the chaotic, decentralized internet that will eventually emerge in the West, but a planned, hierarchical network built for coordination rather than communication. There is something else in Glushkov's vision, something deeper than mere technical specifications. He genuinely believes that OGAS can save socialism. The socialist project, he argues, is being strangled by the impossibility of rational planning at scale. The market mechanisms of capitalism are anarchic and wasteful, yes, but they process information through prices in a way that allows coordination without central planning. Socialism rejects this mechanism, promises something better, conscious, rational planning for human needs rather than profit. But without computers, without a system like OGAS, this promise is impossible to keep. The planned economy collapses under its own informational complexity. OGAS, Glushkov believes, can make the promise real. The opposition. The proposal lands in Moscow like a grenade. Glushkov presents OGAS to the Central Committee of the Communist Party in 1962. He presents it again in 1963. He writes reports, gives lectures, lobbies tirelessly. Some powerful figures are intrigued. Alexei Kosygin, who will become premier in 1964, is sympathetic. The military sees potential applications. Younger technocrats in the planning apparatus recognize that something must change, but the opposition is fierce, and it comes from unexpected quarters. The bureaucrats of Gosplan and the various ministries understand immediately what OGAS means for them. If Glushkov's system works, if it can actually coordinate planning automatically, then what happens to the millions of people currently employed in planning and coordination? What happens to the power structures built around the control of information and resources? A factory director's authority comes partly from his ability to hoard resources, to hide reserves, to manipulate reports. Regional party bosses derive power from their role as mediators and allocators. The entire Soviet middle management class exists because coordination is impossible. Without them, OGAS threatens to make them obsolete. The opposition masks itself in ideological language. Critics argue that Glushkov's system is technocratic, that it reduces the complexity of socialist planning to mere calculation, that it threatens to replace human judgment and party leadership with the cold logic of machines. How can a computer understand the revolutionary spirit of the working class? How can algorithms account for the subjective factors of historical development? Some even resurrect the old Stalinist critiques of cybernetics, suggesting that Glushkov is importing bourgeois methodology. But beneath the ideology, the calculation is simpler. OGAS is a threat to the existing power structure, and power protects itself. The financial opposition is more straightforward. Glushkov's cost estimates, even in 1962, range from several hundred million to over a billion rubles, depending on the scope and timeline. By the late 1960s, as the specifications become more detailed, the estimates climb higher. This is money that would have to be diverted from other priorities. The military wants it for weapon systems. Heavy industry wants it for new factories. The space program wants it for the race to the moon. Every institution, every ministry, every power center in the Soviet system is competing for limited resources, and OGAS represents a massive bet on an unproven technology for uncertain returns. There is also genuine technical skepticism. The Soviet computer industry in the 1960s is struggling. The best Soviet computers are reverse-engineered copies of American designs, usually several years behind the state of the art. Domestic production is limited. Quality control is poor. Components are unreliable. Building 20,000 computers is a fantasy when the country can barely manufacture hundreds. Creating a standardized network across the vastness of the Soviet Union, spanning regions with different technical capabilities and infrastructure, seems nearly impossible. And there is the question of data. OGAS depends on accurate, timely information from every node in the network, but Soviet enterprises have every incentive to lie. They overstate their needs to get more resources. They understate their capabilities to keep plans manageable. They hide failures and fabricate successes. This is not a bug in the Soviet system, it is how the system functions. Everyone games the numbers because survival depends on meeting the plan, not on telling the truth. How can Glushkov's network work when it will be fed garbage data from the start? The debates drag on through the mid-1960s. Glushkov publishes a book in 1964, Introduction to Cybernetics, that becomes a bestseller by Soviet standards, selling 200,000 copies. He is building public support, making the case to the technical intelligentsia, but in the halls of power, the momentum is slipping away. The partial victory. In 1970, after years of lobbying and compromise, Glushkov achieves a partial victory. The government approves a scaled-down version of OGAS called the All-State System for the Collection and Processing of Information for Accounting, Planning and Management, mercifully shortened to OGAS in practice. But it is not what Glushkov envisioned. Instead of a unified network, it will be a loose confederation of ministerial systems. Instead of 20,000 connected computers, it will be a patchwork of isolated computing centers that may or may not be compatible. The budget is a fraction of what he requested. The timeline is extended indefinitely. Glushkov accepts what he can get and tries to build something real from the compromise. Throughout the 1970s, elements of the OGAS vision are implemented piecemeal. Automated management systems appear in various industries. Computer centers multiply. The Kiev Institute of Cybernetics, under Glushkov's leadership, becomes a world-class research institution, training generations of Soviet computer scientists. But the unified network never materializes. The different ministerial systems use incompatible protocols and standards. There is no central coordination because the ministries refuse to cede control. Data sharing is minimal. The optimization algorithms Glushkov developed run on isolated machines, processing incomplete information, generating plans that are ignored or overridden by human bureaucrats who don't trust the outputs. A small example illustrates the larger failure. In 1972, the Ministry of Ferrous Metallurgy implements an automated planning system for steel production based on Glushkov's principles. The system works technically. It generates production schedules that optimize for efficiency and resource use. But the factory directors ignore it. They have their own informal networks, their own ways of securing resources and meeting quotas. The computer's plan doesn't account for these relationships, so the computer's plan is worthless. Within 2 years, the system is relegated to producing reports that no one reads. This pattern repeats across industries. The technology works, but the social system resists it, the American parallel. While OGAS withers in the Soviet Union, something else is happening in America. ARPANET, the US Department of Defense's experimental computer network, sends its first message in October 1969. The message is supposed to be login, but the system crashes after LO. It's an inauspicious beginning, but ARPANET persists. It is not a centrally planned system for economic coordination. It is a research project, a tool for academic computer scientists to share resources and collaborate. It has no grand vision of reorganizing society. It is decentralized by design, built to survive nuclear attack by allowing messages to route around damage. There is no hierarchy, no central control, no optimization algorithm. And precisely because it has no grand vision, because it is small and experimental and academic, ARPANET faces less bureaucratic opposition. It serves military and research purposes, so it gets funded without threatening existing power structures. It grows organically, connecting more universities, more research centers. In the 1970s, hobbyists and enthusiasts begin building their own networks using cheap microcomputers that are starting to proliferate. These networks connect to ARPANET through informal arrangements. Standards emerge not from central planning but from rough consensus among participants. By the early 1980s, the pieces are falling into place for what will become the Internet, TCP/IP protocols, domain name systems, email, bulletin board systems. It is chaotic and inefficient and duplicative. Everything that Glushkov's rational planning mind would find wasteful. But it works. It works because it requires no central authority, no grand coordination, no trust in a benevolent planner. It works because its decentralization is a feature, not a bug. The irony is almost too perfect. The capitalist West, supposedly dominated by anarchic market forces, creates a computer network through unplanned organic growth. The socialist East, supposedly committed to rational planning, cannot build the planned network its brilliant theorists design. The decline. Viktor Glushkov continues working through the 1970s, but his health is failing. The years of 16-hour days, the stress of bureaucratic battles, the disappointment of watching his vision dismembered. It all takes a toll. He suffers a heart attack in 1977. He returns to work too soon, driven by the fear that if he stops, if he rests, the entire project will collapse completely. In the late 1970s, a new generation of Soviet leaders begins to rise, and they are less interested in radical reforms of the planning system. Leonid Brezhnev's era of stagnation settles over the country. The economy is sclerotic but stable. Oil revenues mask the inefficiencies. Why risk a massive infrastructure project when the system, however dysfunctional, is muddling through? Glushkov writes a final, impassioned letter to the Central Committee in 1978. He argues that the Soviet Union is falling behind technologically, that the failure to build OGAS is crippling the economy's ability to adapt and compete, that the window of opportunity is closing. He is eloquent, urgent, precise. The letter is filed away. On January 30th, 1982, Viktor Glushkov dies in Moscow at the age of 58. His death receives official notice. He is a hero of socialist labor, an academician, a winner of the Lenin Prize. But the system he dedicated his life to building dies with him. The what-ifs. Historians and technologists have been playing the counterfactual game with OGAS ever since. What if the Soviet Union had built it? What if Glushkov had won his bureaucratic battles? What if the resources had been allocated, the standards enforced, the network constructed? Some argue that OGAS, if built, would have failed catastrophically. The informational problems of socialist planning are fundamental, not technical. No amount of computing power could overcome the incentive structures that made Soviet enterprises lie about their capabilities and needs. The network would have been fed false data, would have generated optimized plans based on garbage inputs, would have made the economy even more rigid and unresponsive. The Soviet Union would have poured billions into a white elephant that made things worse, not better. Others argue that OGAS could have worked, or at least worked well enough to matter. Modern supply chain management systems, corporate resource planning software, algorithmic logistics. These are all descendants of the kind of optimization Glushkov was proposing. They work in capitalist corporations coordinating thousands of suppliers and millions of products. Why couldn't they work at national scale? Perhaps the Soviet Union fell not because socialist planning was inherently impossible, but because it attempted socialist planning without the technological tools that could make it possible. Perhaps Glushkov was right. Computers could have saved socialism. A third view suggests that OGAS, if built, would have been something stranger and more interesting than either complete success or complete failure. It would have become another layer in the Soviet system, another site of negotiation and gaming and adaptation. Factory managers would have learned to manipulate the network's inputs, just as they manipulated paper reports. Regional bosses would have found ways to control their nodes, to use the system to enhance their power rather than reduce it. The network might have made some things more efficient while making other problems worse. It would have changed the Soviet Union, certainly, but not in the straightforward way Glushkov imagined. We will never know. History ran its experiment only once, the parallel universe. But here is what we do know. In the 1980s, while the Soviet Union is stagnating, the personal computer revolution explodes in the West. Apple, IBM PC, Microsoft, a generation of entrepreneurs and hackers creates a mass market for computing. In 1989, Tim Berners-Lee invents the World Wide Web at CERN, a system for linking documents across the internet through hypertext. It is not planned. No central authority designs it. Berners-Lee just releases it into the world and lets it grow. By 1991, when the Soviet Union collapses, millions of people in the West are online. Email is common in universities and tech companies. Bulletin board systems connect enthusiasts. The internet is still small, still mostly academic and military, but it is growing exponentially. The web is about to make it accessible to everyone. The former Soviet states experience the internet as something that arrives from outside, fully formed. There is no gradual build-up, no domestic development of network infrastructure and culture. One moment you have a state television and censored newspapers. The next moment you have access to the entire world through a computer screen. The psychological shock is immense. Some of Glushkov's students and colleagues from the Institute of Cybernetics become successful in the new economy. They build websites, start software companies, help bring internet connectivity to Kiev and Moscow and the other major cities. They understand the technology intimately. Glushkov trained them well, but they are building a capitalist internet now, driven by profit and freedom of information, not the socialist coordination network their mentor dreamed of. The pattern, the story of OGAS, is often told as a story about the Soviet Union specifically, about how communist bureaucracy killed a brilliant idea, how totalitarian rigidity prevented technological progress. But this is too simple. The pattern OGAS reveals appears elsewhere, in other contexts, in other systems. Large-scale automation projects, attempts to rationalize and optimize complex social systems through technology, fail regularly in capitalist countries too. Enterprise resource planning implementations destroy companies. Smart city initiatives become expensive boondoggles. Algorithmic management systems in warehouses and gig economy platforms create new inefficiencies even as they optimize narrow metrics. The problem is not unique to socialism. What Glushkov discovered, what he perhaps understood better than he could articulate, is that organizations resist rationalization because rationalization threatens power. Information systems are never neutral. They encode assumptions about what matters, what should be measured, who should have access to what data. Building a system like OGAS means making choices about these questions, and those choices have winners and losers. In the Soviet case, the losers were the middle layers of bureaucracy whose power derived from their role as information gatekeepers and resource allocators. In capitalist cases, the losers are often middle managers whose judgment and relationships are made redundant by automated systems, or workers whose skills and autonomy are eliminated by algorithmic control. These systems may be different, but the resistance pattern is the same. There is also the deeper question of whether complex social systems can be fully rationalized at all, regardless of the political context. Friedrich Hayek, The Austrian economist and a philosopher argued in the 1940s that the knowledge required to run an economy is dispersed and tacit, embedded in millions of individual decisions and local contexts. Central planning fails, Hayek claimed, not because the planners are incompetent or the computers insufficient, but because the knowledge they would need to plan rationally cannot be collected and processed in principle. Prices in a market system aggregate this dispersed knowledge automatically without anyone needing to understand the whole. Glushkov was aware of Hayek's arguments, though he couldn't engage with them openly in the Soviet context. His response, implicit in OGAS, was that computers changed the calculation. What was impossible with paper and human bureaucrats might become possible with networks and algorithms. But Hayek's deeper point was about the nature of knowledge itself, not just the technology of information processing. If Hayek was right, then OGAS was doomed from the start, not because of Soviet bureaucracy, but because of the inherent limits of rationalization. The legacy. Today, elements of what Glushkov envisioned are everywhere, just not organized the way he imagined. Amazon's logistics network coordinates millions of products and thousands of warehouses through real-time optimization algorithms that would have made Glushkov weep with joy. Google's search indexes are computational marvels, processing queries at a scale that dwarfs what OGAS would have attempted. China's social credit system and surveillance infrastructure represent a different kind of national-scale information network, one designed for control rather than coordination. But no one has built what Glushkov actually proposed, a national-scale computer network designed to coordinate an entire economy through central planning. The closest approximation is probably the internal systems of the largest multinational corporations, which use enterprise resource planning software to coordinate global supply chains and production networks. But these are private systems, optimizing for profit, embedded in market economies where prices provide the signals that guide allocation. The internet that did emerge is in some ways the opposite of OGAS, radically decentralized, anarchic, optimized for no one's plan but enabling endless unplanned coordination through protocols and standards. Yet it faces its own set of problems that Glushkov would have recognized. Monopolistic control by giant platforms, surveillance capitalism, the breakdown of reliable information in an ocean of noise. Perhaps the internet could use some of Glushkov's rationalist impulse, some mechanism for conscious coordination rather than just emergent chaos. The Institute of Cybernetics in Kiev that Glushkov led still exists, now part of Ukraine's National Academy of Sciences. The building houses modern computer labs and continues to train mathematicians and computer scientists. In the lobby, there is a statue of Viktor Glushkov, bronze and imposing, staring into the distance as if still seeing his unrealized network shimmering in the space beyond. The questions. What do we make of Viktor Glushkov and his failed dream? Was he a visionary whose ideas were ahead of his time, killed by the short-sighted bureaucracy of a dying system? Or was he a technocratic utopian whose plan was fundamentally flawed, who believed that social problems could be solved through sufficient computation? The answer is probably both and neither. Glushkov was brilliant and genuinely motivated by a desire to make socialism work, to prove that rational planning could deliver prosperity without markets. His technical ideas were often prescient, anticipating developments in networking and distributed computing that would come decades later. But he underestimated the social and political dimensions of his project, the ways that power and information are intertwined, the resistance that any system faces when it tries to make the implicit explicit and the informal formal. OGAS failed, but the questions it raised remain urgent. How do we coordinate complex systems? What is the right balance between central planning and distributed decision-making? Can technology solve political problems, or does it just shift them into new domains? When is optimization liberating, and when is it oppressive? We live now in an age of big data and artificial intelligence, of algorithmic management and the smart cities, of platforms that coordinate millions of people without anyone planning the coordination. The internet giants process more information than Glushkov could have imagined, run optimization algorithms that make his linear programming models look primitive. But they use this power to maximize engagement and extract profit, not to coordinate production for human needs. Could we build something different? Could we create computer networks that enable democratic planning, that give communities tools to coordinate their economies rationally without markets or central bureaucracy? Or are the problems Glushkov faced, the incentive structures, the knowledge limitations, the power dynamics, fundamental barriers that no technology can overcome? These are not questions about the past. They are questions about the future we are building right now. With every server we rack, every algorithm we deploy, every protocol we standardize. Viktor Glushkov's network was never built, but his vision of using computation to coordinate society rationally, to replace invisible hands with visible systems, to make the economy serve human needs through conscious design rather than emergent chaos. This vision has never been more relevant. The computers are here. They are more powerful than Glushkov dreamed. They are networked globally in ways that make his most ambitious plans look modest. The technical obstacles that defeated OGAS have been overcome 1,000 times over. So what is stopping us from building what he imagined? Is it that we have learned his vision was impossible? Or is it that we lack his courage to even try? The network that could have changed everything was never built, but the idea remains, waiting in the space between what technology makes possible and what power makes permissible, asking us to imagine what coordination could mean if we had the courage to plan it differently. Viktor Glushkov dreamed of a network that would save socialism. Perhaps what we need is a network that could save us from our inability to choose our future consciously. In the end, OGAS failed, not because the computers weren't powerful enough, but because the society wasn't ready to give up the power structures built around inefficiency. The question for us, living in our own age of technological possibility, is whether we are any more ready now. The bronze statue in Kiev still stares into the distance. The network it envisions still shimmers there. Unrealized, impossible, necessary. What will we build in its place?